Welcome to
Science! This apparatus is to demonstrate the action of a fuse and earth wire in electrical equipment and how they will protect you from an electric shock in the event that it becomes faulty. Here is a model of a kettle which is plugged in. We can see three wires. The blue wire is the neutral wire. The green and yellow wire is the earth wire. The brown wire is the live wire, and here is our fuse. The kettle is now plugged in and is working normally. This is indicated by the lights in the kettle. The current flows into the plug through the fuse, into the brown wire to the kettle, then back through the neutral wire to complete the circuit. If the earth wire becomes disconnected, the kettle will still operate. We can see the lights are still on. But if another fault occurs, like the live wire touches the metal case of the kettle, when you touch the kettle, this will cause the current to flow through the user to the ground. We can see this as the lights on the person have come on to show the current passing through them. Now we will switch off while we replace the earth wire in socket 1, but we will leave the fault with the live wire connected to the case of the kettle. The path through the user to the ground still exists, but there is now a lower resistance path through the earth wire to the ground. So instead of the high current passing through the user, the high current will pass through the fuse, melt the wire, breaking the circuit and rendering the appliance safe. Let's switch it back on. Note how quickly the fuse wire melts. The fuse is there to protect the user and the equipment when too much current flows by disconnecting the circuit, switching it off. The earth wire is there to provide a low resistance path to the ground, so preventing electric shocks. Metal appliances in the home, such as cookers and washing machines, have an earth wire connected to protect you if a fault occurs.